Ugh. Oh my gosh. Bat. Not good enough. Okay, so. Oh. Oh, I feel it. Wow. I don't know. We're gonna wait for people to show up. Well, like, not. I'm giving it a minute before I explain what's going on. That's the respectful thing to do, probably. Wow. I just saw something funny. So, you're probably wondering what the fuck is going on here, and frankly, I wouldn't have an answer. Yeah. Pretty cool. I am going to give a fair warning. Oh, I should see if this is correct first. Properties, default. Let's use that one. Okay. Okay, so I have had a very large amount of alcohol. And we're gonna see if I can do this. Because, yeah, you know what? I'm tired of this. Welcome back to ReactOS Adventures, or whatever the fuck I'm calling this anymore. I really don't know. And we're going to be finishing the driver. Really, is what it comes down to. I am going to organize this in a way that I can bring in all of the code at once and submit it. And have a code base that is logical and is easy to understand. So the reason I need to do this, thank you for working on ReactOS. Yeah, it's fun. It's a fun time. The reason I need to do this is because in order for us to sit there and allow people to extend this, which is going to have to happen eventually, we need this to be right from the start. So we've talked a lot in the past about hardware support, getting the right IRQs, and doing all this stuff to try and make everything work. But what it really comes down to now is this. I know for a fact that our kernel interrupt priority system works. I have aggressively tested it now. I have verified that everything it's doing is what we need it to do, and we can now 100% guarantee that the interrupt priority system works. This means that if interrupts get shared, it should be fine. It should be fine. So, what have we learned through all of this now? Well, after working on the how for a while, I've learned how to take this PNP dispatcher and figured out why it's a failure, why it doesn't work, and what resources we need in order to make this work. And we figured out how to implement these interfaces if we wanted to, so we could get the different connections into HAL working. We figured out how to do ACPI sleep. We figured out how to make a driver that works on Windows. And we figured out how to do all of that in a sane way that allows us to be like Windows 10. So not XP, not Windows 2003, like Windows 10. In the act of doing that, it has allowed us to go in and figure out what resources will end up actually being needed to boot, what resources we need in order to create the PDO for ACPI, and we fixed bugs in a couple spots. That's funny. We've done all of this just so we can eventually do what we set out to do, to create a ACPI driver, a working HAL, a working PCI driver, have it interface with the kernel in a way that's not going to explode. And yeah, so what we're not going to do is we're not going to implement something that's identical to Windows. I haven't been. I mean, I'm almost done here now. This is the cleanup part. This is where everything comes together and it becomes a tangible, mergeable object. So while it's not going to instantly be very Windows quote-unquote compatible, all of the internal logic will be very accurate. It will have the ability to parse everything that UACPI can, which is basically everything. And it will allow us to have the foundation to take this system and extend it into something we want to use. So we know that here we basically have everything we need to go in and find all the resources for devices. And yeah, I mean, that's a lot of what ACPI does, is find transition states and find devices and transition devices. And I mean, I could go on about it for hours, but really the point is that we've done all the research. So now when I write this, while the interfaces aren't going to be perfect, the interfaces will be compatible with ReactOS, and then the internal logic of this driver will be compatible with Windows. So yeah, I'm very tired of working on this. It's been years now, and we're reaching the end. So I've done all this stuff to try and make everything available to the kernel. So now we're going to clean it up. And now we're going to figure out some kind of organization that matters. So, I mean, this can be done in so many ways. But what I think we'll end up with during the stream is something mostly usable. So, yeah. I mean, that's about it. So here's what I'm thinking. We're gonna need our paint.net. Bump. 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 I think that what ReactOS needs to do now, we have this map parsing code. Yep, so true. It is absolutely, it can feel like the hardest. We've got a little bit of a mess here. This just parses through the map table to find all the IO APIC information. The APIC itself is now fine. It's going to be able to do what we need it to. And yeah, I mean, that makes sense. I have code in here for all of the SMP branches. And this is all fine now. Let's start here. I'm going to go ahead and pull in the latest changes because I'm going to need them, I think. Some of this code I'm going to write today is going to seem kind of weird, like not complete, but most of what my day is going to be spent is most of my day is going to be spent trying to deal with building this platform out so I can add code back in and be done, really. That's what it comes down to. So I have a whole bunch of stuff in here that's vaguely how it would work. It's just an older version of everything, so I mean, it should be fine. So the part we need to understand as we're doing this is what is the FDO of the architecture, what's the PDO of the architecture, and where's who. So one thing I really struggled with early on is understanding the ACPI PDO. The ACPI PDO, so the physical device object, is basically this file in HAL, okay? So you have the ACPI PDO right here, and it basically takes in the ID of the ACPI HAL and slash of the PNP ID of ACPI x64 based processor. So if you look at here, this driver details hardware ID is ACPI APIC. Okay. This creates, this HAL is the ACPI HAL root device, while the child of it is the ACPI compliant system, which is this, below is ACPI.sys, and has this hardware ID that you see right here and here. So basically what ends up happening is that this ACPI ID is the child of the ACPI HAL, which is how this works right now, so it's not that much of a shock, but the idea here is that we need to be able to understand what resources ACPI requires in order to load, and while this is close, there was bugs in it, and I had to fix those bugs. Bugs like finding the right IRQ for things. Not great. So there's two things that get, how do I say this? There's two things that end up getting queried that really, really matter. This resource requirement of the ACPI, going in here, it checks for the PDO type being ACPI PDO, and just queries the ACPI resource requirements, which is a function that's right here. Yeah, here. So it creates the IO resource descriptor list, blah 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 blah. It's a shared interrupt that gets the SCI IRQ from a table. So it's a fixed table, can't change it, it's fixed. In fact, it's actually usually the same thing over and over again. So if you actually look at this, you go to resources, whoop-de-doo, look at that. That's a mess, right? Wow. Anyway, it's usually the same thing over and over again. So once we have that IRQ resource, this passes it to the kernel to let it know that it's reserving this for it. The point here is that we end up needing to have it be the right thing. That's why I've made the patch that I did. You can see my name right here. Yep, 4 days ago. Cool. It just fixed the redirection of it, so it was an accurate IRQ detection. And then things worked a little bit better already, which is kind of funny and ironic that it's been like that for so freaking long. Oh, well. Yeah. So we understand that the physical device object for ACPI, so basically the thing that generates the ID, is in HAL. That makes ACPI.sys itself the functional device object for that ID. So I tried to organize this here, but it didn't really end up making sense. So we'll change it up a little bit. Okay, so I'm going to create a new file, ACPI cleaned. So we know that we have a driver entry, which is just going to be main.c, main.c, whatever, okay. If we pull this information all right here, we can just kind of say, okay, this is the same thing. That's the same thing. We can get rid of some of the garbage in here and get rid of that. Okay. We have ACPI devices here, which just is going to hold the device data, which these structures don't make any sense, to be clear. I don't think they're logical, so we'll change them up a little bit. Anyway, so what we know is we do this, we do this. We'll start doing this correctly from the start. I'm going to generate the comment header. No, I didn't want to do it. This is, yep, that's what I wanted. It's still not close. Fuck. Okay, I'm just copy and paste it. I wanted to be clever, but no, it's not going to let me be clever right now. Okay, this is what I wanted. So, this is the ReactOS ACPI based API driver. This is core source file for that. Blah, 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 blah. We'll change this. Change this. We'll change this. And we'll change this. I don't want to do GPL ever again. So it's MIT. Okay. So, yeah, we know. Oh, hang on. Root header. Yeah, we're gonna do this. We're gonna try. Okay. UACPI. ACPI device IDs and structures. Fuck off. Yeah. All right. So now we have our header. So now it should be less cranky if I try to generate it. So we know that our entry point into the driver goes here, and it tries to find a bunch of information about stuff. We'll ignore this for now because we'll find this later in proc information. So I'll just close this for now. But we know, stop. We know that everything here is for the functional device object because the physical device object is owned by HAL. So there's a functional device object portion, and because this enumerates other devices, there's a portion for creating physical device objects. That's important to recognize the difference. And it's important to recognize the difference because if you look here, I don't think the person that wrote these headers originally that I basically ripped from ACPI-CA fully understood, because the device extension from the bus itself from whence PDOs are born. So that's true. That's very true. I'm sorry. I just said the opposite of what I was going to say a couple seconds ago. Whatever. So this is private ACPI data. This is common data shared between both ACPI itself and the physical devices. So yeah, having it split like this makes it more confusing. So let's fix it. We know that this ACPI device header exists. If we go here, we want to keep this device PNP thing. We know that there's the that's not really what I wanted to do actually. System power state, device power state, previous PNP state, device PNP state, and then is FDO, right? Not all of this really makes sense. Oh my god. Okay. Fine. Fine. Not all of this really makes sense for the ACPI bus private data. So that's what this is going to be called or something. So ACPI bus private FDO data context data. I'm going to change the comments. I'm sorry. I really fucking hate these comments that do this. So this is what this is. This is all this is. It doesn't try to share information between its children. This is what it do. All right. This is important. So we can probably just remove this. We know this is an FDO. We know that basically information. Yeah. Child PDOs. It just there's something to be said about comments that exist because the variable name isn't good enough. Okay. This makes a lot more sense now and is a lot simpler. So we'll put this here. We'll put this here. Get rid of that. I actually like PDO device data as a name, so I'll keep that. Get rid of that. This is the handle for it. We're going to say UACPI handle now. All right, so this can be disabled for now. All right, so now we know that this is the FDO of the device, data, context, blah, 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 nerd shit. And yeah, so we can do this now. People are really nice. Okay, so we can do this now. So I know what all of this means. It makes sense looking at it instead of just kind of being a little hard to grasp. Okay, so here's what I want to do. We know that this is the private information, and if we look at here, we can see that when we go to bus PNP, which I guess is in bus, yeah, I mean, it's different. So we need to separate what is an IRP that's getting passed down to the PDOs and what is an IRP that's just being handled by this FDO. The reality is This is just an FDO. This is shared. This is, crappy naming scheme. So instead of add device, we're going to do add FDO. And it's going to be really nice because it's going to make more sense. So we'll create fdo.c or ACPI fdo.c. Go in here. We'll go in here. I should be able to generate the header now, maybe? Generate me file header. No! God! Generate me file header. Use me.c as a reference. It's useless, actually. I was trying to give it the benefit of the doubt, but it's useless. All right, cool. So this IRP responses will have ACPI bus PNP, which isn't going to be in this file. Bus PDO PNP, so ACPI FDO PNP. So there's this that exists. Create FDO. I like the bus prefix a little bit. What do you guys think? Bus prefix or just ACPI? What is superior? That was really nice. I think for the cheese. All right, let's say bus, FDI bus PNP. Wait. Because the bus is created. Nope, I don't like bus. SACPI. Create FDO, ACPI FDO PNP, and then start FDO. And that's what I'm going with. The other problem here is that I kind of do this weird thing where I mix the rules of my naming rules a little bit. Why am I doing that? Maybe just ACPI FDO PNP. We're all nerds. It can be a name. ACPI can be a name on its own. We're nerds. That makes sense. Okay. So, destroy PCO. So we have FDO PNP, start FDO, create FDO. There's two of those for some reason. Okay, so let's copy these over. Add driver. This creates the FDO. My bus FDO, size of FDO data. Need it define an editor config? I don't know. Wow. This is really inconsistent. Hang on. Why did I do this like this? I don't like it. Oh, some of this is copied from the old driver. I was reusing code. Capitalize names of variables and functions. Yeah, why is it camel case? Why did I do that? Okay. Yeah, this is wrong. All right, we got that now. We really don't need to null this out. Bye-bye. Boop, boop, boop. Okay. So... oh yeah, wait. Okay, so paged code, sure. Wait, no, that's not what I want. All right. Add device. Physical device object, status. Device object, status. Status. Return status bonk 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 list child PDOs. We don't need this. We don't need this. Initialize PNP state. Data device PNP state. Yeah, that makes sense. That makes sense. I don't mind doing that still. I just need to be like that. Okay. Device data, device flags. Not sure why that's like that. This should be like that. This exists, you can just ignore it. Here's the top of the attachment chain. Just like that. Next lower driver. Lower PDO, because this returns a device object, so I don't know why it was called that before. What the fuck is that? Actually, I don't care. Bye-bye, bye-bye, okay. Now we've got this, we'll do that. We don't actually need that anymore because we never, ever, ever needed a go-to in the first place. Not sure why it tried to make one. Device extension, so if it doesn't have enough memory, it'll put it in there so there's no crash that'll happen anyway, so there was no point for the go-to. Okay. All right. So that's create FDO. And I could probably pull a George now and just actually start documenting this stuff because I know what they're doing. Let's see, how does he do it? Brief return param. Brief return param. Brief return param. Oh, my bad. Physical device object, driver object. Yeah, that could be like that. These are both in. See, every time I have to code raw stuff, I have to go through and I have to do this because it just ends up being every question anyway. I feel like this one's kind of obvious. I mean, yeah. It returns the result from only one thing, doesn't it? Yeah. There you go. Now I'm good. Surely you see, this isn't C++, and there probably is an extension, but I'll just write it really fast. It's fine. I don't have the energy to deal with it right now. WAP. Okay. So we have that. Start FDO. Because I'm pretty sure, yeah. This just returns these ACPI enumerations. So here's what I'm going to do with this. This is where I'm going to start doing things a little different. For one thing, this isn't going to change this. Oops. We have ACPI bus data. I'll get rid of that. Have you tried Sea Lions, a JetBrains ID? No, I've not. ACPI, start FDO. Start FDO, just another IP. This is going to initialize UACPI. Minimal functionality, but not enable ACPI itself. FDO data. The reason why this matters is because what you need to do is there is a interface between ACPI and HAL that decides to actually go ahead and kickstart ACPI. It's not something you can just enable. ACP or the HAL has to get to a certain point where it's actually ready to start initializing ACPI that it cares. So there's just a thing there. It has to be done like that, otherwise Windows gets kind of fucked, wucky, you know. Not sure. I'm gonna go ahead and say static success. ACPI initialize early ACPI. So doesn't really do a whole lot of stuff. Yeah, I mean, it is what it is. This goes in here, goes in there. Which, again, if you look at this a little bit, it doesn't actually, you can take a flag in and it won't actually put in the initial thing. So what I might do, I think this is something I can just use. I don't know. Let me see if officially it's something I can use. Yeah, it's not. So we'll call this twice. Or do we just do this later now? Because if I want to do this right, I mean, I don't really see a reason we can't just save it for later. It's fine. Let me see what UACPI does, or not UCPI. Let me see what ACPI CA does really quick, just to make sure I'm not wrong. Initialize subsystem, initialize tables, create volatile registry tables. And it starts enumeration. So let's say that, oof, this is rough. We'll just do this. Keep it like it was. Then we have FDO, PNP. Which, if we look here, is start device, stop device. That's just different device states. And yeah, I mean, that's about it. All back down the chain. Okay. Let's clean this up. DO device data. Device object. Doesn't this get, like, moved? I can see that. Oops. This PDO data comes from calculate the number of PDOs actually on the bus. So I do see why that's there. Let me change this up a little bit. What flavor of it? That's all the same in this driver. There isn't actually a difference. The reason why is because PDOs. The reason why is because in order for that to work, it handles all of the no. So it's all the same because ACPI is generic and then handled into this driver, but all of the APIC PIC stuff is handled by HAL. So HAL is the physical device object for ACPI. It creates all the stuff and resources it uses. And then what ends up happening is you don't care about the interrupt too much. There is a couple pieces in the code you do care, but they're very small actually. You try not to care about it too much. List of child PDOs. List of child PDOs. Child PDOs present. Child PDOs present. Oh, it doesn't even do that. I don't like that actually. Relations. Links. Yeah, I just kind of mixed both drivers together and it ended up being kind of. What did I name it? I don't really remember now. Like slower PDO. Yeah, that makes sense. Yep, that's cool. The point here is just to make something PRable. We don't need to worry about that. Silly thing, and it's really complicated comments. A little happier with this. This feels kind of weird. Wow, why make everything so big in the file? It's so hard to read. Okay, so get rid of that. Child PDOs. Grab that. This just handles the IRP requests for okay, so that's good now. Dude, what the heck? Wow. So that's better. Let me see. Okay. Now I should be able to go in pre-comp and say ACPI FDO. And people will actually know what this does. Won't be a big mystery. Mostly to myself in like a year when I have to come rewrite and add more code to this. Because that will happen. That will happen. Keep it PDO device data. I think that's logical. Only the PDO device data actually has an ACPI handle, and that's going to change a little bit because we're going to use the UACPI handle. I do actually like this comment, but I don't like the / very much, actually. Cool. Yes, maybe. Maybe I should make my own include file. Nice. Okay, so we got start FDO, which goes here. Or sorry, bus power? No, that's not where it goes. Also, this should be fixed. Okay. Add device. Create FDO. Create FDO goes into the PNP function, which goes in there, and there's bus power. Which if we go in here, I'm pretty confident that doesn't do much useful right now. Yeah, so this dispatches into its children or into its root. So there's an FDO power. So we'll kind of do it like this. We'll create a debug file. It'll be a debug.c. Debug.c will contain all of this string to whatever the hell information. Go in here. Go in here. Yep. Yep. Have a good night, David. Okay, so we have all this stuff here now. Have this here. Dispatch create close, of course, is just that. So put that there. ACPI dispatch, and we should probably fix the lettering. Yeah. That can go there. That can go here. That can go here. That can go there. We'll also have registry stuff. Which will be close to this. There. Okay, and it will make a lot of sense now. Get rid of that, get rid of that. Can do that now. We can call that. In fact, I can probably just take this entire thing. If this doesn't work, there's something wrong. Okay, so we can just say steps then. All right. Looking good so far. So we have the FDO file, the registry information, which we'll kind of ignore. I didn't write it, so we'll have to grab the original copyright information from it. Bus power, bus dispatch. ACPI, transition power, which if we look here, we're doing this weird thing with common data, and I don't understand why. Okay. Don't need that, don't need that, don't need that. I guess common data makes sense though, then. But I don't really want to do it like that. I don't really want that discrepancy there too much. Parent FDO. Let's say we'll keep self. And then not only that, we'll keep self and is FDO. We'll get rid of FDO, get rid of self. Keep at the top. Global, or sorry, shared device data. That has to be at an offset. Mm-hmm. In fact, that has to change. That's, I know that seems kind of stupid, but it kind of has to happen like that because it really doesn't make sense otherwise. Is ACPI FTO? What the heck? Oh, yeah, I see what that's doing. That's pretty much it. And we don't really need to do this. I'd rather just do it inside the function. Stack status common data. Yep, that's the whole plan. Common data status. So, it'll work now. ACPI, transition power. Oh. I'm going to change this too. The way this function works isn't the most clear thing in the world, actually. Like at all. For one thing, this is an N. Create close, this can just be here, that's fine. But this is kind of silly. This is trying to say that it wants to change how this works. I want to explicitly say that this isn't the solution to everything, and that this data is only used for a couple things instead of being like just now being integrated. No. I have been working on this for the better part of like a year and a half now, I think, and I've been working on remaking ACPI HAL PCI for like 4 years, off and on, mostly on. So it's what's happening right now is I'm taking my existing code and trying to make it look clean so we can PR it and we can just be done. It's done is the thing. It's not like just now being integrated. It's just now being made into a pull request. This is me reorganizing everything so I can throw it into place and make a pull request, because I started just writing code and I didn't really think about how it should be organized or cleaned up. So it just worked. And then now I'm just now working on organizing it. So that's the entire plan. A little different. Yeah, it already works. It's just now I'm trying to make it so I don't get hammered in the PR for stupid shit. Like the capital letters, the cases, the organization of data. It doesn't always make sense. Blah, 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 blah. Blah this, blah that. So yeah, that's it. That's what I'm doing. So this is just me organizing stuff so the PR itself is ready. So, I mean, it'll look good when it's done, and then we'll have a driver, and then, yeah. Unless we want the PR to sit there for 2 years because of a bunch of comments. I don't. I really don't. So I'm thinking that this is only an FDO function, or sorry, a PDO function. So we'll take this away and we'll create ACPI PDO. And an ACPI PDO will have a bunch of functionality that does this stuff. So we'll say ACPI PDO PNP, ACPI PDO dispatch control. I mean, it'll make sense. So if we do this, we'll call a function. If we do this, we'll mark it as complete. And then, yeah, so now we'll create what this function actually does. So we have ACPI PDO. We have that's created by HAL. The ACPI FDO sits below. That creates a bunch of child objects on the bus. Inside this is UACPI. UACPI tells these two how to communicate and communicates back with the PDO information about switch this to not a line, an arrow. This communicates information that way. This communicates information that way. This communicates information about, you know, sleep capability, etc. This communicates information about CPI resources, IRQ. Right. This talks to PCI. These two talk to each other. Well, it talks to that. Well, this creates the FDOs and stuff, right? These are ACPI PDOs. For example, AMD GPIO .sys. Okay, does this kind of make sense? Cool. We'll need that for explaining what this is for. Okay, so now we need to understand. That's why we're making that separation. Now we have to go find the PDO dispatch control. A PDO dispatch control can do a couple things. Like passing data, so we'll just create the two things we want. So these will be here. These will be here. Go here, go there, go here. This can be commented out for now. Status and TAPI. Go back over here, we grab these two. Yep. That goes here, which takes in IRP stack, technically. So I'll just do this. And in fact, actually, yeah, we'll do it like that. So this takes in the IRP stack. Stack location, IRP stack. Do that. What's on the rough to-do list after this? Oh man. When this PR is complete, what we need to do is go in and create the arbitration for the IOAPIC. So we'll have all this information about possible resources. We'll take it, we'll throw it into the IOAPIC, and we'll adjust it accordingly, which most of the code for that's done. I just need to also clean that up, which is the same thing I'm doing here. We take that information, we throw it in, and then we have, resource loading for ACPI drivers. Then we do the same thing to the new driver, PCIX. PCIX then makes some adjustments to be able to actually use the new information and some things to complete it, and we start being able to pass interfaces between the new PCIX handler interfaces. So once all of that's done, those are 2 other PRs right there. Once those are done after that, which isn't that long from now, that's way easier stuff than this, we want to be able to... I think what I'm going to actually do is integrate a couple drivers I wrote, but after that, I will integrate XHCI. After that, I will integrate my new KD USB, and after that, I will integrate KD Net. After that, I will finally, after all that work, which is the next 2 months or so, maybe less, we will integrate the final changes to fully enable UEFI boot. And we will be able to boot and install on UEFI devices. That's it. Also, drivers will load for some stuff. We'll add NT6 functions a little bit as we go, so you can install some drivers. But pretty much that's the idea. It's a very... I'll expand the list to be more detailed, but there's a very static set of things going on. Not that long anymore. It was a lot worse a couple years ago. From there, once all that's done, I'm home free pretty much. I just start doing what I want to do originally 4 years ago, which was finish WDDM. Because I'll be able to test. That's it. That's all this is for. It's all just so I can finish WDDM. But yeah, we'll have the ability to boot on USB 3 machines. We'll have the ability to boot on UEFI machines. You'll be able to install and use your mouse input devices on modern systems. The experience won't be fantastic because you won't have a lot of drivers, but you'll be able to do basic things. And for the most part, just plug. My goal right now is to plug in my USB hub with like a storage device on it, a mouse and keyboard, an audio or whatever I want to test with, and just plug in something to debug, which is probably a network card. Shove those 2 into any system, debug my driver, install it, boot it, good, go, switch to the next device. That's really what it comes down to. It'll be very good. I wouldn't recommend installing off on those systems, but it won't be slow, and it won't be unstable, and it won't be that bad. It'll just be kind of weird that you're doing that, but it'll work. Yeah, pretty much. That's it. Going back here, we will find children PDOs. ACPI PDO.c. Yeah, it sounds like a lot, but that's because it has been a lot. It's been a lot. It's itself not that much anymore. It's doable. It's going to happen no matter what. It's too late to run now. This is what's happening. So, yeah. All right, so this will kill the IO control if it's on the FDO and dispatch to this PDO dispatch control function. Otherwise, okay, return. Yep. Yep, there's a plan. The plan's reaching the end here. Yep. It's gonna happen. All right, so this is done now. So I might as well add those entries in probably. And PNP. So let's do PNP now. It makes my main file a lot smaller. You can actually see where things go. Shared device data. Do that. S. I don't know. I mean, ReactOS is old. It's so old. It's older than me. There's no sitting down and trying to like figure out what people were thinking 100%, because in the end it's like different time, blah blah blah, different time there, different time here. I wish I had a better way to really go through and understand what they were doing, because a lot of the things I've found are kind of ridiculous, but it is what it is. I know that after 2005, the ability to boot without ACPI degraded every year. So while ROS was going forward, it was probably getting harder to do anything. Yeah. I mean, that's a good goal for it. I could see it doing that. I don't know how well, but I could see it doing that. ACPI dispatch PNP. I mean, it's very likely that that ends up being what we not entirely sure what happened there. In a few places. Yeah, that's literally why I'm doing this. I'm already gonna. I was gonna get knitted so bad. It was. Yeah, I mean, the code had 3 different styles in it. I did not try very hard when I wrote it, but I just wanted to write code and get this done. So I just said fuck it being perfect, rewrote from scratch, and just did it till it was done. So, yep. Okay. dispatch PNP, transition power, ACPI, dispatch PNP. Now we've got that. Now we've got that. Device control. Looking good, looking good. All right. That is our root file pretty much. Even playing one band one wise a headache with wine trick dependencies and REST. Yeah, but I mean ReactOS will still have to install stuff for dependencies, but we've talked about making like the ability for it to like hook into your install and just download the stuff you need, which is pretty cool. Kind of like what Windows Update does, huh? A little bit. But yeah, I mean, there's avenues there we can do. Or definitely can make it easier. Debug. I'm going to try and keep this consistent. But pretty much. Yeah, I don't know. Transition power. That snappy driver wrap is broken. Yeah, it is. It's so broken, but it's broken in a way that this will probably start to fix, so I don't know. And hi, Kat. Good morning. I'm not going to go too much longer because I mean, this is going to take a couple days just to like iron out all the code style inconsistencies and yeah. But I'm making this template really quick first. FDO, PNP, yeah. So right, some of these are really bad. Some of these are really bad. It also feels like the switch statements aren't really doing what they should be. That one. That's the one I use. Yep, that one. Cool. Your voice does not match up at all with what I assumed for some reason. Yeah, that's fair. I don't blame you for thinking that. Zero blame from me. Just some of this code is just I have one feature instantly implemented. This is what I'm doing right now is just been. I've tried implementing so many things I enjoy, and I keep switching to being like, oh, you know what? Maybe I should just work on something I enjoy for a while, and then I get stuck because of this. This thing's breaking everything. This is the foundation of so many problems. I need it to be fixed. I need it to be fixed now. So I'm fixing it. That's really what it comes down to at this point. CPI, start FDO. Better. A little better. Silly AI is realizing what I'm trying to do. Still better than the sequels. Yeah, so true. This is also weird. I don't know why they decided to do this other than just to annoy me. Oh. That's why. It's reaching the stupid line limit. I forgot that thing existed. Does it still exist? I don't actually know. I think that's kind of an old ReactOS thing. Okay. All right. So we are getting somewhere. Dispatch PMP. So this is the FDO. So status equals that. Yeah. Okay. Somehow Palpatine returned. I love that clip, actually. It makes me laugh. I don't think I'm going to sit there and try and fix this. I think it's a little out of my wheelhouse. Regardless of the functional use of the 80-column line limit, I do appreciate when it forces control flow to be simplified. I think it depends, because in my experience, people will start using that as an excuse to write things in a way that make no sense. So yeah, that's my opinion. I think Wi-Fi is a big one. So I have a patch to implement encrypted connections that I need to deal with, but it's not. It's something I did for a convention that Ross went to, but I haven't had time to turn that into a functional PR because, frankly, it just hasn't been the top of my priority list. When I solve this and I can actually install ReactOS on some hardware that I care about and it not screw itself in the foot, then maybe I will continue that patch. It wasn't very complicated, but not right now. There was some work though on that. It's not, it did work. I have like images of it somewhere. Somewhere. I don't have a patch for everything. I have stuff for things that bothered me. So I'll go in and I'll get pissed off with something, so I'll go fix it. I just want the bare minimum of ROS to work, and the bare minimum doesn't. Oh god. And there's a picture somewhere in here, and I don't even remember what it is. Yeah, there we go. Yep, there you go. Ashenvale, WP enabled, nope. And it connected, and it is a WPA2 network. So the work was there. It did work, but it was for a convention, and frankly, I haven't had time to clean it up. But it was there. Somewhere. Yeah, somewhere. Okay, I'm feeling better about this organization now. I think it makes more sense. Yeah. A lot of that stuff is things that need polish. So WPA needs a lot of polish. XHCI needs a little bit. KDNet and KDUSB need a mediocre amount. But yeah, it depends. IOCTLs. It's because Python's not actually that useful. Hopefully he's into the bare metal traditional Chinese, yeah. Booting anything after 2005 is insane. Ross just doesn't know what it wants to do with its life. So PDO, FDO, transition power. So let's say it's less confusing. I don't know. I think you're selling yourself short. No, it doesn't. It might look like it's working, but I pretty much guarantee you that it's burning up every time you do that. What was it? Whatever. Stats 1. Yeah. Every time you boot ROS, it burns something, I promise. It doesn't look like it does, but it does. PDO transition power. It also runs everything at like the worst performance, so, or performance mode or whatever. I mean, just all around, not a fun time. I would just move to pure C and just get that skill in. You're jumping around so much that you're not learning anything. And the learning part's the most important thing. It doesn't really matter what your skill level is. What matters is that you're learning. Or if you think you have an affinity or not. Look at the debug logs coming out of it. The debug logs aren't really the problem. Although, yeah, it probably looks like it sometimes. We have a lot of stuff we don't really need to print that we do. It's always kind of weird me out, actually. It's another thing I look at that I'm just like, why? Yeah, I'll replace some of these weird, just kind of bland doxyoxygen comments later. I'm just putting the basic idea down. The performance was iffy. The performance doesn't exist. I'm not sure there's a better way to put that into words. It doesn't really exist at all. Transition power. So now we can replace this with status equals FDO transition power and status equals PDO transition power. See, look, that makes way more sense than PNP plug PDO plug PDO, whatever the fuck. I don't know why it was written like that. Let's do PDO PNP next. Isn't there a to-do list on the wiki or something? There's a lot of information about what we're missing, but it's not really out of date. There's just a lot more. Some of it's not as important as other things. So it's kind of hard to measure. Yeah, there's a lot of information there that helps, but isn't quite right. Well, it's right. It's just not quite enough. Status. Okay. Weird things like a wish list. Yeah. I've even been trying to add things like, how can we be better than Vista? By doing things Vista broke. Vista break. It's somewhere in here. I made a wiki page that's all about the things Vista broke that we could try to address, but it ended up not being that long. So, yeah, there you go. That exists. FDO, PNP, PDO, PNP, FDO transition power, FP transition power. Then there's add device. That add device function is probably that's add PDO or FDO. Vista's a rather low bar. No, it's not. Vista's the foundation to a lot of things. When we start addressing stuff and make more like Vista, it's not really about the visual aspects. I don't care about those. It's more about us trying to make something that's going to provide the foundation for future ROS. I mean, it's just what it is. Okay, so this creates the FDO. The FDO then gets called if it's dispatcher, and the dispatcher calls start device, which calls start FDO to start ACPI. Okay, so that is better. A lot better. Let's clear what's actually happening here. There isn't. There's not. There's one coding style, and we're just really bad at following it. So yeah. Not so fun to use. Oh, it's not about the usage. It's about the functionality. There's interest in creating a Vista style interface, but that is absolutely not the most important thing here. This probably can just return status. Forgot to do that. Dispatch control returns the status, which is here. missing anything? There's transition power. There's PNP. Is more important than arrow? Well, yeah, but we have to be able to run applications, don't we? In order to do that, sometimes some parts of arrow are even needed now. So it is what it is. We just need to do what we do. Implement what we struggle and run into. But honestly, yeah, right now I think more important than even running applications is being able to boot our kernel at all. So here I am, fixing that. When you unplug a USB device, parts of it. Well, I guess a lot of it. Like 60%. There's some use after free errors in the USB stack, but that's not as critical as the fact that it just fires off the wrong IRQ half the time. What? Yeah, so it's 60% of the problem. Pretty good, but not all of it. What does this even do? Oh, it initializes the power state. That makes sense, actually. Yeah. That's funny. There's some funny Poe code in here. I remember what this does. This transition power is actually a really accurate name. I forgot that I wrote that already. That's probably why I chose that name subconsciously. Okay. This handles that. More accurately, let's pull up this information. This let's not add that last bit. It's scope Poe next power IRP, and yeah, that's a fair complaint of XP. I don't like XP, actually. That's a thing with me. I really don't like XP. I've never liked XP. I didn't like XP when I was using it. Not that I ever really used it a whole lot, but it sucks. It all sucks, actually. I really don't like XP. Anyway. Bus Destroy PDO is built for the child, I think. Yeah, kinda. Bus destroy PDO. That never actually ends up getting called. I didn't know that. Initialize PDO? Wow. They're really bad at this. There's a whole bunch of functions here just for... Yeah, that makes sense actually. Start device. Stop device. The start device, I guess, gets called by that. This gets called by the creation from the CPI bus. I know, I'm sorry. I know that's controversial. I know people like XP, but I never did. My mom, like, used XP and then forced me to use Mac OS because it kept being freaky, and then I tried using XP anyway, and I understood what it was, why she hated it. Because it just never worked quite good. Ever. At all. So, yep, that's a thing. The evaluate functionality seems to mostly just be, I guess, ACPI get name. Eval element get size, ACPI argument length. I see what this is doing. The enumeration happens because plugin device creates the FDO, which gets called by the enumerate devices, which gets called by the initialization sequence. So that's why the old driver works, and Windows does it something close. I have my notes here. So organizationally, we'll have something like, I don't know, create ACPI create PDO, ACPI create PDO, we'll pass in information about that and generate its resources and initialize PDO, which will finish the initialization. Personally, Windows 7 was the best in my honest opinion. I used 7 the most. My favorite was Vista. But I liked 7 almost as much anyway. It didn't end up really being that different. The reason why my favorite was Vista is, unfortunately, I went from a horrible XP experience just to, like, go to Vista and it fix all my problems with XP. And then I really liked Vista for that. But it was never a strong competition. 8 and 8.1 are good when you fix the start menu. I'm okay with 10. I actually don't hate 10 at all. I've never hated 10. I bought 10. No, I didn't buy 10. I got 10 for my birthday. I got an RTM CD, so a DVD, because we got an actual license and DVD for Windows 10. It was like the RTM version. I got it for my birthday because my birthday is in July. So Windows 10 came out like a week or two, I think. Let me verify that. Release. Okay, yeah. No, it wasn't even that. So, yeah, it came out 4 days before my birthday. And my mom got me a CD. And I actually liked 10 a lot. But it got worse over time. And I don't really like 11. But early 10 was really cool. Early 10 was really cool. Yeah, so this will go here, that goes there, that completes that request. We can just grab this interface, I guess. I don't really know. Yeah, start device, stop device, remove device, query capabilities of device. This file just gets long. God, I remember getting that for my birthday. Whoa, man, what birthday was it? Was I 14? I think, yeah, I was 14, I guess. I was 14, and I was going to get my first desktop. Like, custom built. So my mom got, like, prepped all the parts. It was an FX system, I think? Was it? I don't remember. It was an AMD system, whatever it was at the time, but... Yeah, wait. I think it was FX. Bulldozer. She put that, all the parts, like, packaged them up, but I think she made me open the CD first to tell me that I was getting computer parts. I think it was the CD I opened first. So I opened a retail copy, or not retail, it wasn't retail, it was like, it was weird. It was a little before the retail released, actually, but it was a DVD. And it had, like, Windows on it, and a key on it and stuff, like the physical key. I think I opened the DVD first for some reason. That's how it ended up being. But anyway, it's a funny story. Yeah, Windows 10 came out the same like month that I built my first desktop from scratch. That with like parts that weren't, used or gotten from garbage, basically. So my first actual new computer was built from parts the same month that Windows 10 released. Maybe that's why I like Windows 10, actually. It's like the start of this hobby escalating. Anyway. So the PDO now doesn't actually have to do that much. If I'm right. PDO, PNP. Sorry, I put these in the wrong spot. These go here. Or does it? No. Because we have ACPI enumerate.c. These go here, actually. And the reason why is because these aren't supposed to be like, owned by the IRPs. These are called because UACPI ends up being called. Yeah. So it creates the PDO, initializes the PDO, then ACPI translate UACPI resources. I'm sorry, UACPI. That looks dumb. Translate UACPI resources. And everything that happens here is trying to is doing the resource enumeration that I did in this other file. And yeah, that does make sense. Because what will happen is this. So we have some logic that enters into the ACPI driver, which calls some functionality to create the FDO. That calls some functionality to initialize UACPI. So how starts ACPI or how creates the PDO device ID to load ACPI.sys, as we remember. Then we have some code that creates the driver entry, then initialize the FDO ACPI.sys being the driver, the functional driver. Above, then we have code that initializes UACPI for every device, and this happens in a loop. So this happens in a block here. UACPI finds a device. Find device. Find device. Find resources. Create PDO. Attach. Start PDO. Start PDO, transition power, and a state. Attach as a link. And it starts from there. So, find device, find resources, create PDO, attach the PDO, start the PDO, transition the power and state, attach as a link, and find device again. And this happens over and over again for every device on the bus. Bus, unless it's PCI. Then it passes info to instead of having this attached as a link and transition its power states, it handles its own power states. From there, the kernel will have devices. how long would this initialization loop take? It takes an incalculable amount of, or a low enough amount of time that I can't really calculate it. It's not a second, it's in the nanoseconds. It's really fast, actually. UACPI itself isn't actually slow. Yeah. Anyway, not super complicated. So, yeah, this initializes the PDO, creates the PDO, translates the resources, and then everything else is the IO control, PDOs, IO controls. That's pretty much it. Which happens not here, sorry, here. In this file, because what happens is that the IRP gets sent down the stack, ACPI's FDO deals with it first, then it passes it to the ACPI PDO file, and it then passes it to the FDO of the PDO. So, yes. And with that, I think I'll create devices like ec.c, which are FDOs built into the PDO driver, which is ACPI, and the FDO is right. There's the ACPI interface and the evaluation.c that need to be done. So eval.c, I'll keep that as is, because that is not my function. That is GL, ACPI interface, .c, then HAL interface, .c. And yeah, that's it. That's how we're going to organize this. That's it. So, I have a plan now. And I'm going to start throwing code in here and put everything back together, and then we're going to call it done. It's probably not going to be that fast, but it will be a couple days. Also, I need to make sure that I clean all these headers up, and I will probably implement more than just the EC driver. There'll be other embedded built-in drivers. But yeah, actually, everything makes a lot more sense now. Cool. Ship it. Fuck, dude. Alright, I am happy with how I'm going to organize this now, and I'm no longer locked in trying to like figure out where things go. I'm happy where things go now. Okay, with this, we've got a new ACPI driver. Once that's done, I will add in the code to here, or just shove it back into ACPI like I did with my original code. That's how weird this original code is, by the way. Yeah. I just embedded the PCI driver into the entire file, or into the driver, ASPI driver, because I was lazy. So, yeah, I mean, it's not perfect, but it will get us there, and that is important. Yep, that's it. I'm going to go ahead and end it here. I'm going to get some sleep. Tomorrow I'm going to start throwing code in here, and maybe, oh God, I hope so. What is PCI versus PCIX? PCIX is a rewritten driver that is meant to be PC compatible. So you see these interfaces, bus interfaces and stuff, right? and PP bridge and bus number. The point here is that there's extra logic in this new massive PCI driver because, okay, compare these two. Here's the old PCI driver, 3 files. Here's the PCIX. PCIX is meant to be actually a Windows driver that works. But yeah, it's very complicated, and I've add more code into it to complicate it more. But the point there is that what that's for is we end up supporting devices that attach to these interfaces that this PCI driver exposes, and so we get more functionality. An example of that is the PC card bus, the I don't remember what it's called. Wow. It's some of the embedded stuff that goes into your laptop, docks, things like that are all handled here, and we don't handle it at all right now, and that's why PC cards and things don't work, because there's no code for it. This driver is supposed to handle that, so you can load your drivers, but that's it. It's just a better driver. It's a bit more complete. It's also more portable. Anyway, that's it. I'm gonna end it here. Have a good night, everybody. Thank you all for chilling out with me and letting me ramble on about how I'm rewriting this and reorganizing it so I can actually figure out what I'm doing. Yeah. Have a good night.